anything else? It is a tangent that goes nowhere. Okay, cool. All right. So thank you, Alyssa, for sharing your charts. And yeah, so this is what you should have down below, which is what Alyssa was able to show. The thing that really kind of made it pop, what really made it stand out, was this reorder function here, right? And so by using reorder, let's go ahead and take a look at that for the folks that are following along at home. What's up?
Mr. Robinson.
Yeah, yeah, what you got?
It's still on your AI screen.
It's on my AI screen. Oh gosh. So everyone's still looking at Cornball AI going, okay, what's going on here, dude? I'm totally lost. Let's see here. Thank you for that little heads up. All right, here we go. So I just hit the question mark reorder to see what reorder does. It's a generic function, so I can use this literally anywhere. It's not unique to ggplot. What reorder does is it creates factor levels out of data. So pretend, for instance, I have two columns of data. I've got names on one column and I've got values on another. And I want, when I plot things out or I print things out in tables, I want those items listed in either ascending or descending order of those values. I can use this reorder function and that will take care of it for me, which is kind of nice. It works really well and it makes life easy because if I go over to my plots here, I've got, I don't know, what is this, like 16, 17 names here. I've got a bunch of values. I could do this manually, but that would be hard and potentially messy and potentially make my code a little bit difficult to read. And what this does is it does it inline in ggplot. And when I read it, I go through, okay, so I'm starting with flights, doing a group by, I'm flagging my canceleds. I'm now going to summarize. So I've got my number of flights and now I've got my number of canceleds, which is just a simple sum of these true falses, which from yesterday, if we recall, true falses in R are the same as zeros and ones. And I can sum them, I can multiply them, I can do all kinds of fun stuff. I've got a mute, which I then pass into a mutate. You'll see here that I did a little kind of a funky thing here, right? A little bit of flair, a little bit of Scandinavian flick. I threw 100 times this ratio, right? And so this ratio is going to give me a number in decimalized percent. So 1% being 0.01. That's a little tough to like read and interpret. When we plot things out, generally speaking, although not always, don't have to. You guys can choose that. We usually think of things in terms of whole number percent, so 2.5%, 3.5%, not 0.025 or 0.03. So I just threw 100 times that just to make it a whole number percent. And then I did a join. So if you remember yesterday, we did joins. Joins are merges, right? And so I did a left join. Left join, if you remember, it keeps everything on the left-hand side. So let me go ahead and do a little comment here. Remember, joins have two sides, an X and Y. And the side of the join is the data we want to keep. Left join means we are keeping X and bringing over Y. Okay. So in this case, I want to keep, on my right side, right, is all the data that we've worked with here, this huge summarize and some mutates and some other things in here. And what I want to bring over, right, is this airlines data, this Y, right? This is now our Y. And I want to bring it over by matching the carrier names. So I've got in my data, do I have it up here? Yep. And my data, right? I've got a column named carrier in my airlines data set. I've got a carrier, right? So if those two things match, I'm going to bring over this name, the values that are in this name. And when I finish all that up, what I have is carrier flights. I got all my mutate stuff, cancel ratio. And then what I'll have is to end it all out is a final column that has name, and that's the name that we brought in from the airlines data set. And then we just go straight into a ggplot. And these things are pretty simple after that. So um, I so Leah or yeah, Alyssa, you had you threw in a mid here for some purple, which is actually kind of neat. I just did blue to red on mine, but we have this reorder in here, and then we adorned it with some different stuff in here. There's two things that I am doing in here that you guys probably haven't seen. One is called theme underscore minimal. You know, hey, what's that? What's that? We haven't seen that before. And I've got theme in here explicitly, and I've got this thing called legend position equals none. So what's nice in ggplot that I don't think you get in a lot of other plotting applications, including what you get in Excel. You do get a little bit in Excel, but it's hard sometimes. I find this to be way easier in ggplot. One, you can apply themes very, very simply, and they're literally just theme underscore. So if I just go, let me open up a web page here, deposit Corteza. Let me go over to how do I bless? Now I'm just all over the place. All right, there we go. All right, let's go to ggplot themes. There we go, complete themes. So ggplot comes standard with a bunch of kind of canned themes. So there's theme gray, theme BW, line draw, light, dark, minimal, classic, void, test. There's a bunch of kind of what I would call like kind of canvases to get you started with, right? And so if I just show, I'm going to comment this out, and we're going to see what happens. So if I just comment this out, um, right, what happens? My background is this kind of weird, I don't know what color you want to call it, light gray. Was it taupe? I guess kind of pinkish peachish something. It's some kind of off-white color, like a darkish off-white color. And I've got these white grid lines on the inside. I've got some tick marks along the axes. And yeah, like it looks okay. But what if I didn't want that background? What if I wanted cleaner axes? What if I wanted something that was just entirely different? We can use these themes here um, to do sort of different things. So we got theme line draw. So a theme with only black lines of various widths on the backgrounds, reminiscent of a line drawing. I've got light. So I got light gray lines in the axes, dark, right? So you've got a dark background or a light background. Classic. What is classic? I don't think I've seen classic. Let's see what classic does. So that's a theme classic, right? So no grid lines, bold axes, tick marks, right? We're kind of cleaning it up a little bit. Um, my personal favorites are BW, which stands for black and white, um, which, theme BW gives you sort of these light grid lines on the interior, which can sometimes be distracting, but more often than not, I like to have them just because they give you a visual reference, just to kind of if you're trying to compare two different lines, like, hey, where was this line at this particular tick mark? And I like being minimal, and so minimal gets rid of all that. And I just have some basic grid lines. So this is kind of over time. I started with BW. Now I've landed on minimal as kind of my standard starting point for my for my themes, and I then sort of work from there. So it's kind of like it's like, in a way, it's sort of like a recipe, right? Like you go online, you look at a recipe, like, oh yeah, this looks like a great recipe for garlic bread, whatever it is, right? And you're gonna read through the ingredients, like, well, I don't have that, or I have this, or oh, this would taste way better. And so you kind of start making little modifications to these recipes, and you end up with something that's a little bit closer to kind of your tastes and preferences, and perhaps is more in line with your visual style. You will, yeah, as you start getting more into plotting and doing data analysis and really showing this stuff, you'll quickly kind of key in on certain elements of style that just work best for you. It's something that kind of emerges. Like at first, like you're just like, oh, whatever. I just need to get the data out. I just don't care what it looks like. Just give me something. Um, but then over time, like you'll just sort of develop like, yeah, and down to like color palettes, right? So here we've got this sort of like blue to red gradient that some people really enjoy. Um, so this is something I've had to learn over time. So my boss, Mark Jensen, who I teach the class with in the fall, he's colorblind. He's just straight up colorblind. And for years, I was generating plots where he couldn't tell one data point from another because he's colorblind. He's like, I don't know what I'm looking at. Like he's trying to tell based off of like if one's like a little bit lighter or darker than the other, but like he had no clue like what any of the stuff I was producing looked like until he finds so I'm like, dude, I'm colorblind. I don't know what this is. And so I actually had to go through and come up with like a colorblind palette, like go look research colorblind palettes. Um, and there's several out there that do a pretty decent job of being I guess sort of sensitive to folks with that are colorblind, but then also but look good, right? Like I want things to look good. And what you'll find is that the better the plot looks, the less colorblind compliant it is. Like you see all these beautiful ones where it's like these like shades of blue or shades of green and stuff like that. Like, oh, this looks just stunning. It's like, yeah, yeah, but for people with colorblind, they can't see anything. Um, and so as you are kind of going through your plots, it's also to be kind of, thinking of like, who is this, who is my audience? Are they able to differentiate in a very easy way? What the different features of my plots, are they able to actually discern one series from another? And depending on, are they printing this on black and white and is it easily readable? Are they seeing this on like a computer screen? Is it going to be blown up on a massive projector? And thinking about kind of how that looks, these are all kind of different elements. So those are minimal, and there are, let me see if I can find a couple. ggplot theme economist. I think based on the economist. Yeah. Theme economist function. So if you guys ever read The Economist, so there's a package called GG Themes. And GG Themes has a bunch of plots that are based off of current publications. So there's one for like 538, there's one for the Wall Street Journal, New York Times, The Economist, Nature Magazine, Science Magazine, and they apply their style guide to your plot. So if you wanted something that kind of looked, if you wanted to kind of pay homage to some of your favorite magazines, they have those themes in there. So that'd be the GG themes. And then lastly, this theme piece here, right? So theme, um, uh, I've got this legend dot position equals none. So if I take this out, what is that going to do? So if I just didn't have this thing in here, right, I would have this legend called cancel ratio, right? And it would show literally a legend of um what the colors mean inside of here. Is that necessary, really? I don't think so. I mean, the whole idea is, right, I want my blues to represent lower values, the reds to represent higher values. Like we kind of see that here a little bit. Um, So is it maybe necessary to have a legend in here? Probably not. And so the way to get rid of that is I can go into this theme parameter inside of ggplot, and I can just say I don't want any theme, I don't want any legend at all. So we can do legend dot position equals none. And you may be asking, well, what else can I do in here? Well, I can do things like plot dot title equals element text, and I can do size equals say 15, right? I can do let's say was it what was it, axis? Yep, dot title dot x equals element text size equals 12. Let's go and do that there. And I'm going to say title here. Title equals um and white nation pictures for MSC Archers, right? So I can just go and run this. All right. So before these two, the X and Y axes titles had the same font size, and now the X axis has a larger font size than the Y axis, right? Um, I can specify the axes X and Y um, individually. So if for whatever reason I've just got a long title and I need to shorten it up a little bit, I can do that. I can set them both the same at the same time, but just axis.title. And now they're both the same size, right? We can set the plot title a bit bigger, right? We can do all kinds of fun stuff. What about the text? Maybe if I want to adjust the text size, I can do axis dot text equals element text size equals 12. Oop. Right. Now I made this text bigger, right? So if I've got a lot of things kind of going on in my charts, I can make things bigger or smaller, right? Based on the font size, which is kind of a neat little feature. Um, yeah. Best thing I can say about the themes, like your plot title, plot subtitle, axis text, axis title, legend, um, dot position, legend dot title. Those are going to be sort of the main elements that you're going to be dealing with in ggplot. Um, Best thing I can say for you guys as far as like, well, how do I do this or that? Google it. Just do Google ggplot theme and then just describe what it is that you're trying to do, right? Axis title size, axis text size, um, legend position, legend font type, position, angle. Do I want my stuff going 90 degrees, 180 degrees, 45 degrees? All those things. There's usually some pretty good tutorials out there, and some pretty good descriptions of how to make those changes. And that's exactly how I've learned to do it. I just, sat here and said, yeah, these grid lines are absolutely messing me up. How do I get rid of them? Do a quick Google search. Or how do I change the direction of my ticks, right? So if we remember, we had little tick marks here before. They're all pointing the outside. What if I wanted them pointing the inside? What if I wanted inside tick marks, not outside tick marks, right? You can do all those different things here very, very easily. So anyways, plots, merge, merge, merge. Let's go on and start diving into today. What I want to have you do is, let me see here. We've done transforming data. We've done some logical tests. Let me see. Let's go ahead and switch gears out of NYC flights for a little bit, and let's do conditionals. We're going to talk about conditionals today, and we're going to use let's see, I'm going to use the baby names. Can I do data? Do I have baby names in here? Baby names is not found. Where is baby names found? Where's baby names found? I want baby names. Baby names, baby names, baby names. Where do I find baby names? Thought it was in here. Let's do a search. Let's do a search. Help. Where can I find baby names? Baby names not found. We're going to do Google search. Uh, are baby names? Package baby names. All right. We're going to install a new package. I thought it was something that was already included. I guess it's not. Let's do install packages. Baby names. Baby name found. What? Oh, Farmer. Yep. Yep. And database. There we go. There we go. All right. So we're going to install a package called baby names. Then we're going to load that library, baby names. And then we're going to hit data, baby names. Let's see now. And baby names has got a lot of data. So we just keep increasing the amount of data we're using here, don't we? So the first data set that we used was cigarette.sw that had 96 observations, and then we upped the ante a little bit. We went to the flights data that had 336,000 observations. Now we're into baby names. Baby names got almost 2 million observations. This is insane. Let's see, baby names. So what's in baby names? As the name would suggest, it is the full baby name data provided by the Social Security Administration, right? So when you have a kid in the hospital, kid's got to be assigned a Social Security number, right, at the time of birth, right? You sit there in a hospital for a couple of days as you're recovering as a new family, and the nurse will come or a nurse administrator will come around and ask you, okay, what is your child's name? And that all goes to the Social Security Administration for reporting, so they can issue a Social Security number. Um, and this data set has all of that information. And so if I open up baby names here real quick, I have the year, I have the sex of the child, their name, and I have the number of times that name was used in that year, or sorry, in that reported year. So the way that we would read this is that in the year 1880, uh, the name Mary was particularly popular. So there were 7,065 recorded instances of children or baby girls being born and assigned the name Mary by their parents. Um, this this proportion value here represents the percentage of babies born with that name. So a little over 7% of babies born, or a little more than 7% of girls born in 1880 um, were had the name Mary. And let's go ahead and actually this proportion. So let's see, prop divide number of applicants that year, which means proportions are of people of that sex with that name born in that year. Okay, good. So what does this proportion mean? Is this proportion of all babies born, or is this proportion of just females born in that year? And according to the data down here, and prop n, so n divided by the total number of applicants in a year, which means proportions are of people of that sex with that name born in that year. So if I were to sum all of these values for females in 1880, I should get what number? What number should I get? If I sum this column for the year 1880 for females, what number should I get? Should I get a zero? Should I get a one?
One.
Exactly. Should be a one. Should be a one. So you're handed some rando data from a coworker who may or may not have been particularly on the ball. You're taking over their work, and you know, let's say you work for the Bureau of, well, I don't know, whatever, baby name statistics, and you've got a report that you're kind of working on, and you want to just validate real quick whether or not what they were working on makes sense or not. The easiest way you can do what I like to call our checksums. These are just simple calculations you can do on the data just to kind of make sure that things are kosher, right? So, according to this data, right, these proportions are n divided by the total number for that year for that sex. So the way I would check that is baby names, right? And I pipe that into a filter, right? So if I go to baby names here, dude, this is just killing me. Let's clean this up a bit. Clean up. I got a lot going on here. There we go. Baby names. Oh, airlines. Baby names. Okay, so I want to do filter by year and by sex. So I want year equals. Well, let's see what we got here. Is year an integer or is year a character? So it's a num. All right. So years equal 1880. And I want sex equal to F. All right. I'm going to do a summarize. And I'm going to do sum prop equals sum. And I'm just going to go ahead and sum this prop number. All right. And in theory, this should equal one. Does it equal one? Pretty close, right? Pretty close. I get 0.932. So is this a fully comprehensive list of values? Perhaps not. Um, but we do get pretty close. We do get pretty close. So why is that? We can think about that later. Um, so they are clearly using something a little bit different here. So they must be using a slightly different N. There must be which means the poorest people of that sex born with a total number of applicants in that year. So there must be. So what this tells you is that there are probably applicants outside this year. So that says 0.932. Let's keep that in here. What if I want to do it for all years? Well, I first want to get rid of this filter, right? And I want to do a group by. Right? Let's do a group by year, some prop year. And that should get me a list of these values right here. So I started from 1880 all the way forward. And I've got 128 more rows. What if I want to plot a diagnostic, right? Maybe this is some indication of data quality here. Let's see. Yeah. Let's do geom line, AS, X equals year, Y equals some prop, right? And I should get something that looks like this. Yo, so it looks like the sum proportion goes up quite a bit here up until 1960, and then it goes down, but roughly somewhere between, call it, 90 to 98% of the data in our data set, right, is covered, right, in terms of all the data that's available. So in other words, we're getting over 90% of the names that are recorded in the United States are in this data set. So there's roughly 10% of names, right, that are not part of our data set. So this is a fairly complete data set, but is not exhaustive. In other words, can we can you guys do you guys can you venture maybe why that's the case?
Can you repeat that?
So why would I why so why would why would I have names not in my data set? Why am I seeing this feature roll off after 19, maybe not necessarily after 1960, but why am I seeing this decline, right? Like we live in the age of computers, right? Like, we have access to all the data. Like, why does it look like I now have access to less data today than maybe I did in 1960?
Is it more compact?
A little bit, but think about it in terms of names, right? Like, maybe it wasn't as popular to have unique names in 1960, right? People had very generic names, right? The composition of the population, right? Like what's happened since 1960, right? We've had a lot more immigration, right? I've got a lot more unique names today than perhaps we did in 1960. I can tell you, I grew up in the 80s, and I grew up in Massachusetts, in Irish Catholic Massachusetts, right? Like I had probably 50 Maries in my first grade class. Um, you know, Today maybe not so much. You get a Marie, but you get a lot more like Olivia's or Skylers or Tamiya's or Alyssa's. You get different nationalities, right? We've got Korean names, you've got Chinese names, you've got Middle Eastern names. I hear my kids say their friends' names. Like, I'm having a really hard time keeping track of my kids' friends groups because it just spans like the full. It's like, Saharsh and the Doves and right, Nikolai's and names that I never heard of when I was a kid, right? And so, but those are going to be, let's say, a fairly small proportion of overall names, right? And so, at some point they just sort of have to like trim off values. And so that's kind of these like one-off unique names are just, they become a bit more common in occurrence. And so rather than just report literally every single name that's ever been reported in the United States, which would be just a ginormous data set, it'd be millions of rows per year. You're right. They just sort of compact it down into something a bit more tractable, um, which is kind of cool. Which is kind of cool. And actually, we can do this, get rid of this filter altogether. Right. And I can do group by year and sex. And I can do sum prop, and I can do color equals sex. Right. And if I do that, I get 2 lines. Right. So it looks like it's more common for girls to have unique names than it is for boys. Right. And part of maybe just, spelling, right? People got different spellings for stuff. Like if it's, Mary is Mary, it could be, Marie, Mari, was it E or Maria, right? Was it Christy or Christina? Is it Christina S or CH, or is it a K? Catherine with a C, Catherine with a K, those kinds of things. Like those are two unique, very distinct names. They sound the same, just spelled very differently. It appears that perhaps those occurrences are a bit less with boys than they are with girls. Does that make sense? Kind of a fun little tidbit in the data, little insights that we surface with our data. Okay. Why did we do that? Well, let's say you're presenting this to somebody who actually does work for the Social Security Administration, and you're telling them that this is an exhaustive list of all names that were published from 1880 onward, and they know what this data set actually is. they're going to say, nah, there's some cutoff here, right? Like, you can pretty confidently say, like, yeah, we're getting roughly, 90 to 95% coverage in any given year. I'm sorry, roughly, 95% coverage in any given year. Um, it's a very expansive list, although not exhaustive list. And but okay, yeah, that makes sense. Like I don't need to know like every permutation of spelling for every name on the planet. I feel pretty confident that right that we've got some that we've got a fairly decent coverage that it's more than 90%. That seems pretty good with that. Let's do some filtering. Yes, ma'am.
I'm getting an error on my last line when I had changed it to add color equals sex. Um, it gave me an error, and I don't know
Show
why.
your screen. Enter the Thunderdome. See what you got. I don't know. I think I might have lost her. That's unfortunate. There we go. Very good. That's why. Get a filter in there. And you're grouping by year. So line two, just go ahead, don't delete it. Just go and put a comment in front of filter with a little hash mark, little pound sign. Nope. Nope. Delete that. Go right in front of the F and filter. Nope. Get rid of that too. Yep. Go put your cursor right in front of that at the very start of line two. Yep. Right there. Put it right there. Yep. And then just hit the pound sign, shift 3, I think it is. Yep. And comment that line out. Yep. Exactly. Nope. Not the comma. Comment. Yep. Bingo. Awesome. So get rid of that filter. Go to line 3, and after year, but before the end parentheses, do comma and sex. Nope, not there. Actually, yeah, hit backspace on that and get it back up to line 2. You want that filter up on line 2. Yep, there you up too far. There you go. Awesome. Awesome. All right, just hit the down key and go to line 3. Yep. And then right after year, do comma sex. Yep, right there. Bingo. Bingo. So when you do that group by, nope, just leave it alone. No, no, nope, nope, nope. Back up, back up. Just leave it alone. Get rid of those equal signs. Yep, perfect. Excellent. Run it. Bingo. Awesome. So what was happening is that when you in that group by, because you're just grouping by year, it was throwing everything else out. And so when you group by year, um, and you were doing the summarize, all it was keeping was year and that sum prop. But you wanted it by year and sex.
Got it.
And so so now you've got year, sex, and then sum prop in your final data. Awesome.
Okay, got it.
Perfect. Cool.
Thank you.
Cool, cool. No. Believe me, I spend obscene amounts of time on this stuff. So let's go over some more kind of conditionals here. I guess be a bit more deliberate about what they are and what they're not. We've been kind of doing some filtering a little bit here and there. Um, I call them conditionals. These can also be called logical tests. Um, the they all kind of mean the same thing, right? At the end of the day, I want to get a true or a false answer out of my operation. These are going to be done almost exclusively inside of the filter commands, which you guys have been doing. And so you guys are familiar with these, right? So, these include less than, greater than, equal to, right? The greater than or equal to, less than or equal to, but also not equal to. And that's what that exclamation point means. Um, I've also heard it called bangs. Have you ever heard bangs? Some people call them bangs, right? Also, I was tutoring a kid one time years ago, and he called the I know it as a pound sign. So anytime anytime you were dialing on the phone, so hit pound 929 or something like that, right? It was like kind of what you did, fall by the pound sign, right? So you type in like a menu on the phone, hit the pound sign. But a lot of people call them sharps. Like if you take music, that's the symbol for sharp. And so I always thought that was kind of interesting. Anyways, another tangent. And then lastly, ins, so group membership. So these are going to be your kind of basic logical tests that you're going to run. These are all going to occur inside of a filter command. And again, I think kind of as we described a little bit in not yesterday's lecture, maybe it was yesterday's, maybe it was the day before. Ultimately, what we want to do with our data, right, is I want a set of trues and falses in my data, right? And I only want to keep those that are true, right? I only want to keep those that are true. And so just to kind of show you what's happening on the back end. So this is literally what is happening on the back end. So if I do a simple filter, so let's go back up here. This is going to be just a simple example to so if I want to do baby names
It's still
and
showing the slideshow.
oh yeah, of course you can't see a thing of what I'm typing, can you? So it'd be helpful. This week's video on YouTube is going to be absolutely hilarious. There we go. All right, cool. Here we are. All right, now you guys can see what I'm working with. All right, so I'm going to do baby names, and I'm going to go ahead and filter. Let's go back over here. I'm just going to say n greater than 1,000. Say 1,000 greater than. Actually, no. I'm going to do a mutate. Let's do filter equals n greater than. Is that going to work? Is that going to do anything for me? It is, in fact, good. All right. Let's go and view that. Let's go and view this. So I'm taking baby names and I'm adding a new column called filter, right? I like to call these sometimes flags, right? Why do I like to call it flag? Because like rarely are you ever going to see a data field called flag unless you're dealing with flag data, like actual like nation or state flags or whatever. And it's also kind of like a little sort of symbol. It's a little sort of indicator to me to say like, oh, like I'm using this somehow, right? Like, I may want to call this filter flag, right? So flag for me is kind of my little indicator that I'm using this to somehow break up my data or differentiate different parts of my data. Like there's some sort of administrative purpose for this, right? So if I forget to comment something, if I forget to um, describe, what this is exactly, right? I kind of know, like, all right, this is a flag, right? So I must have been using this to do some sort of filtering or some sort of segregation in my data. So if I go and view that, what do I get? So I got a filter flag over here. And if you remember, I wanted it where n was greater than 1,000, right? So this operation here, right? This is my calculation, right? This is my logical calculation. I want n greater than 1,000. So if n is greater than 1,000, it should throw a true. Otherwise, it should throw a false. And what do I see? Got a bunch of trues in here, and then I got a false, right? And so when we do our filters, right, this is literally what R is doing. It's doing this operation, right? And then it is then just keeping. So if I just do a filter, I can just do filter flag, right? Right. So if I do a filter flag, it's only keeping those values that are true. So you see it goes down to just 1,000 and boom, goes up to the next one. Goes down to 1,000, boom, goes up to the next one. So there's no values in here under 1,000. It's exactly what the filter command is doing. The filter is doing two things. One, it's calculating this logical statement, this kind of conditional, this true false, and then it is removing that data that is then false. So that's kind of what we're doing with a filter. So let's go and get rid of that. Actually, that are true from our logical statements. In this case, and these logics can be anything. It can be evaluating numbers, whether or not they're greater than, equal to, less than. Um, it can be whether or not they are members of groups. You can also combine these things, right? So n is greater than 1,000. Say n is greater than 1,000. And sex equals f, right? You can do those things. And I can kind of combine these things by just using the parentheses, right? So if I encapsulate this as a parentheses, now this is a statement, right? But what if I wanted females that had n greater than 1,000, or males where n was greater than 2,000? Right, now I've got a compound logical. Well, the way I would work that is I've got one here. So I want to have two separate statements encapsulated here. And then my or statement is just this up and down key here, or. And I can do n greater than 2,000 and sex equals n. And that closes that, and that closes that. So what this will return, this is going to go through, and it's going to say, okay, return true if either of these two logical statements inside these parentheses are true. It's effectively what we're trying to do, right? So before, I had this nice inclusive list of, it had to both be a female and n was greater than 1,000. Now I'm adding another one where it's like, okay, I want females with n greater than 1,000, or males greater than 2,000. That make sense? So if I run this, I'm going to go ahead and clear this out. View. Thank you, summary that nobody asked for. So if I go into here, I've got a bunch of Fs in 1880. That's right. So let me see. Ooh, we've kept a bunch of stuff in here, didn't we? So we got a bunch of things in here. Or, oh, I must have made a mistake. I must have made a mistake. So N is greater than or, so equal to M. So this one is saying it's true. Oh, here we go. My bad. Duh, because I'm not deleting anything. So I got a bunch of trues here. That's right. Okay, good. We're on the same page. Sorry about that. I forgot we weren't actually filtering. We were showing what it was looking like as a filter. I got confused. So okay, here we go. All right. So females greater than 1,000. True, 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 true. False. Right. This one's less than 1,000. You gotta scroll down all the way down here now. Get to the males. Where's my M's? Where's my M's at? Come on. Let these go for quite a while. Keep scrolling, keep scrolling, keep scrolling. Oh, here we go. I get some trues now. All right, now I get the males. True. And once I get below 2,000, I get to a false, right? So this correctly evaluated, right? So I get trues only if it's M greater than 2,000, or pick up all up here. Come on. F's greater than 1,000. So I do my filtering here. I uncomment that filter flag view. What should I see? I should see nothing but trues here. I got F's going down to 1,000, and I've got M's going down to 2,000. Then we restart all over again. So this is just to kind of show you what R is doing on the back end. And it's also really good if you're doing a really complicated filter operation here. This is also a really good way to sort of just check what you're doing before you like fully commit to a filter. So what I could also do here is just going to comment this out. We can just do simply filter n greater than 1,000 and select F, or n greater than 2,000 and sex equal M. All right, and these are going to do the exact same thing. That should give me the exact same thing. So look at that. I should see the same data, right? So go down to 1,000. Yep. Now get to M. It only goes down to 2,000. Yep. Now we're to the next year. Does that make sense? These are just complex filters, right? So, rarely is our data like, when we're looking at stuff, it's not really common to see like a real simple filter like, oh, I just want all the data from 1990 to today. No, it's usually some kind of complicated, right? You've got a lot of data. You've got, a million different variables. You've got a gazillion observations. And, let's say it's DMV records or Social Security records, or it's payroll records, or whatever it is that you happen to be looking at. And you're looking for a very, very unique segment of that data. It could be, employees that are married with a specific health insurance provider, so many years of work experience with a particular title, right? These filters, these logical statements, or these conditionals, they can really stack up. And you may not just want one very unique thing. You may want a couple things all at once. And so we can use, we can encapsulate our individual statements inside of parentheses. And so make sure that this one is are evaluating on their own, and then we can combine them with ands or ors. What if I change this or to an and? What do you think would happen? So I want men or women, right? What if I change this to an and?
Is it just more data?
Could be. Let's find out. I have no idea. No data, right? No data. Why is that? Can you guys,
Because
can you?
it's not combined. Like you
Well,
can't combine men and
well, I mean,
women.
you could. Yeah, exactly. No, it's exactly right. No, that's right. Right. So the sex, that's the thing, right? So, so if I have, let's say I have an observation that's a female, right? And it's greater than 1,000, that's going to evaluate as true, right? Let's just do it. Let's do an example, right? Let's just do, for example, uh, F and let's say N equals 2,200. Okay. So let's say that I have a row, right? Let's say one of our rows here oh, that we have here, it's sex is equal to F, and let's just say N is equal to 2,200, right? So that's our just example, mental example. I run through this. Okay. So is N greater than 1,000? 2,200? Yes. Is sex equal to F? Yes. Okay, good. All right. And so this whole thing is true, right? What about this one? N is greater than 2,000. Is that true? Yep. Sex equal to M, F no. So this whole thing is false, right? So this is true, this is false. And well, if one's true, one's false, and I've got an and statement, that's going to result in a false. So for each and every row, because we don't have a category where sex is both M and F, um, every row is going to result in a false. So for conditionals, I'm going to go and get rid of this. So in general, so we do for ands and so for and statements, right? Both need to be true. Or actually, not both. All true for result to be true, right? So if I have an and statement, right? In order for an and statement to be true, every single one of those logical uh, evaluations I'm running, they all need to be true in order for the final answer to be true. For an or, God bless. For an or, only one needs to be true for all to for. Right? So for an or, right, only one of my criteria, right, that I'm evaluating needs to be true. So if I have students from Spelman or Morehouse or Georgia State or Georgia Tech, right? Only if I only need one of those criteria to be true in order for the whole thing to be true, right? In order for that statement to be true, only one of those things has to be true. If it's students from Spelman and Georgia Tech and Morehouse and Georgia State, all of it, because it's an and statement, when you're evaluating whether or not that student should be included in your criteria, right? All of those things need to be true, right? So even though we're kind of saying in our heads like, oh, I need students from Spelman and Georgia Tech and Georgia State and yada yada. It's like, okay, yeah, that's kind of how we're saying it, but when we evaluate it, we're actually evaluating as an or. So I want a student who is from either one of those schools, right? Not is a student of all of those schools. Because, I mean, I suppose you could be a student of like 4 schools at once, although I don't know how that'd be really kind of possible. You guys would never sleep, I think. Um, but with an and, right, all of your statements need to be true. For an or, only one of those statements need to be true. So if you're thinking about like, okay, if I want to filter my data out, do I want to use ands or ors? This is kind of the way that I think about it. That make sense? Cool, cool. All right, awesome. Yeah, that's like this is like the hard part here. This ands and ors, right? This is where I spend a good chunk of my time if I'm working with some really like data heavy stuff. Um, and I've got to get really exotic with my filtering criteria. I spend a lot of time really thinking about, okay, what is it I want to keep and what is it that I don't want to keep. It really comes down to these ands and ors. Let's see now. Doop-a-doop-a-doo, doop-a-doop-a-doo, doop-a-doop-a-doop-a-doo. Let me see here. Let's just do a quick example. I'll give you guys a few minutes to work on this, and then I think we'll call it a day because I know you guys know how to filter. I'm pretty confident in that. Let's go and do generate a line plot. And my criteria, let's say journal plot from 1880 onward of boys with the name Ryan. How about that? Okay. So start with baby names and give me a plot of the general population of, say, the number of boys with the name Brian. Let you guys work on that for, I don't know, a couple minutes. If you got questions, ask. I'm going to eat my mango. So it's general line plot. So baby names, filter, what I want. And what's my thing? Name. Into G plots. X equals here. And y equals n. Uh, um, um, babies, title, yeah, this, does width get cab? I never know. I don't think it does. With um, there you go. Because I am me, and I'm just going to be a little bit extra. Theme W. There we go.
Mine is going a different direction.
Really? So it's starting from 2000, it's going backwards?
Or it's starting from 1980 and it's going down.
1980 going down.
Or,
Sure.
oh, I didn't
What'd you
put
do?
eight. Is it from
Mm,
1880 that we have to put? Oh, okay. I put 1980.
yeah. Yeah. Well, the data starts at 1880. And so you can just leave that criteria off if you want
Oh,
to.
okay. Okay.
Yeah. It's up to you. It doesn't matter. So so for all my Brians out there, and I'm gonna go ahead and I'm gonna show you a neat little thing that's called geom V line. So geom V line generates vertical lines, geom H line generates horizontal lines. Horizontal lines intercept the y-axis, vertical lines intercept the x-axis. So x-intercept equals 1979, the year I was born. I'm one of the I'm like peak Brian. I like peak Brian. I'm my parents named me at the height of the Brian mania in the United States. The 70s were just a great time to be a Brian. Classrooms were just packed full of Brians. Everyone I know who is named Brian is is somewhere in this data set. So you can spell Brian with an I, right? How else can I spell Brian? You spell with a Y, right? So Brin or Bryn. I don't know why anybody would want to spell a name with a Y, but they do exist. Or name equal. Actually, instead of doing an or, tell you what you do to make this really interesting. Do an in. Be Brian or Brian. Right? Or Brian. Oh, let me see. Ooh, do you see this ugly looking thing? Kind of looks like I don't know what this is. Is there some jaggies here? Can you guys guess what's going on? So let's see now. If I do this, right, what do I return? I should return not just one data set. No, I'm sorry, not just one thing. I'm gonna return 2 rows. And now I'm trying to print 2 rows of data in one line. And this is, if you see this right here in your plot, this means that you got some more filtering to do. You've got some more work to do because you're trying to plot too many things at once, is what this tells you. So what I want to do now is I need to summarize total n equals sum n. Because instead of returning just Brian, I'm now returning Brian with an I and Brian with a Y. So now I'm returning 2 rows of data for each year. And I'm just trying to plot the n. And so R is just literally trying to plot both those things at once. So I need to actually sum both of those together to get the total amount. So let's go to total n here. Total n. I should get now a much nicer. No, I didn't. I did not. Because I forgot to group by year. Right. So I want to group by year and some of those totals because I want a year total. There we go. That's what we want. So this returned not 1 row of data, but 2 rows of data. So now I need to group by the year and then sum both of those together to get a year count. So yeah. So when did this peak happen? Right, I got a peak here. Right, when did this peak happen? Let's go ahead and just inspect it visually. Scroll down here. It looks like peak somewhere in the 70s, above 40,000. Yeah. So 1972 was like peak Brian mania in the United States. Everyone was naming their boy Brian. There's a ton of Brians out there. I don't know why. For whatever reason, it just became popular. And that's sort of the data that we see. And yeah, names kind of come in and out of fashion. Right? They come in and out of fashion at different times. And they kind of give us a little hint of what's going on in society at the time. So that's all I got. Homework. Do I have a homework for you guys over the weekends? No, I'm not going to give you guys homework this weekend. Is it going to be a nice weekend? It's going to be a great weekend. Why? Because you're not going to think about plots. You're not going to think about data analysis. Or maybe you will. Maybe you're going to go into the weekend armed with this information. You're going to go, holy smokes, I see data and plots everywhere.
I have a question.
Yes, ma'am.
For the homework, I wanted to ask, how do you want the homework sent? Because I've tried to make it into an R script and I don't know how to do that, so I've been sending them as PDFs.
You can send as PDFs. You can just, so if you want to send it as an R script, just literally save it as whatever .r, and I'll just have your code in there, and I could then just run it. So if typically I'm asking you for a plot, just save the plot as like a PDF or an image and just send it along with your R script. So typically like an assignment like this will have the R script and then it'll have the plots like kind of separately. You can just save those and send those over. That's fine. And then over the weekend, I will. Sorry, go ahead. I apologize.
Oh, if we do send them as PDFs, do you want screenshots of the graphs?
If you go to export over here, you can save it as a PDF or an image and just send those.
Oh, okay, got it.
Yep. Yeah. So save you from doing the screenshots. Yeah, and then I'll take a look at the homeworks you guys did this week and give you some feedback on them. And hopefully, let me see where we're at. I know I'm like 5 minutes over. I do terribly apologize. You guys have a class at 10 o'clock, is that right? Okay. Yeah, I'll just leave it at that. We'll talk about projects on Monday. And so I think we're far enough along. We're like halfway through the course. You guys have more than enough to do, I think, basically the project if you ever wanted to. So, but I got to figure out like what that exactly is going to be. And so I've got homework this weekend. You guys don't. How about that? Cool. All right. Well, enjoy your weekend. enjoy the lecture tomorrow, and I will see you guys on Monday.
Thank
Have a
you.
good day.
Awesome. Bye.